Unit 1, Foundations in Geometry. This is Lesson 1-4, Inductive Reasoning, Conjectures, and Counterexamples. Lesson 1-4, use inductive reasoning to identify patterns and make predictions based on data. Use inductive reasoning to provide evidence that conjectures are true, or provide counterexamples and make predictions. Here's a warm-up, some past information. Number 1, something. Points are points that lie in the same line. So on the same line would mean collinear. Same kind of thing, but this time they lie in the same plane. That would be coplanar. The sum of the measures of two something angles is 90 degrees. That's complementary. Find the distance between points A and B. Distance, not midpoint. There's our formula. Plug it in. We're going to subtract our x's, square it, add it, subtract our y's. Use our calculations. You can put it in desmos if you want, and your answer's 5. Find measure of angle C if angle C and angle D are supplementary. That means they add to 180 degrees. We have the angles written as algebraic expression, their measures, so we can add them up and it equals 180. So 3y minus 5 plus 8y plus 20 equals 180. We need to combine like terms on the left-hand side. So 3y plus 8y is 11y, and negative 5 plus 20 is 15. So there it is simplified. Get rid of the 15. Do the opposite of adding 15. Subtract 15 on both sides, and then divide both sides by 11. Y is 15, but be careful. That is not what they're looking for. They told us to find the measure of angle C. So we need to plug it back into that expression. Measure of angle C is 3y minus 5. Plug in the value of 15 we found for y, and the measure of angle C is 40. Find length of segment SR if R is the midpoint of segment SU. So if it's the midpoint, those lengths are equal. Set them equal to each other. Now we are going to have to distribute on the right-hand side. So we'll need to multiply the 2 with the 5a and the 2 with the negative 4. So 6a plus 4, just bring it down. 2 times 5a is 10a, and 2 times the negative 4 is negative 8. So there we go. Variables on both sides. Subtract the smallest one. Subtract 6a on both sides, you get 4 equals 4a minus 8. Add 8 to both sides and divide both sides by 4. A is 3. That option isn't there, but then that's not what we're ultimately looking for. We need to find the measure of segment, or the length of segment SR. We have an expression for that, which is 6a plus 4. We know the value of a, plug it in. A is 3. Calculate, our answer is 22. Still warming up, we're finding the midpoint of, no, they tell us the midpoint of segment AB is 3, negative 2. So I wrote that down. I'm stacking things over there. Coordinates of A is 7, negative 1. And what are the coordinates of B is what we are looking for. Let's look for our pattern. To go from 7 to 3, we subtracted 4. Do it again. We're at negative 1. To go from negative 1 to negative 2, we're subtracting 1. Do it again. We're at negative 3. A is our answer. In the given figure, measure of angle GFH is 43. I marked it. We need to find the measure of angle GFE, which is right there. Those are vertical angles, so they are the same. Answer A. New stuff, terminology, inductive reasoning, making a conclusion based on observations and patterns. When several examples form a pattern and you assume the pattern will continue, you can apply inductive reasoning. Inductive reasoning is a process of reasoning that a rule or statement is true because specific cases are true. You may use inductive reasoning to draw conclusions from a pattern. A statement you believe to be true based on inductive reasoning is called a conjecture. So a conjecture is a concluding statement reached using inductive reasoning. Examples in practice. Find a pattern and list the next 5 terms of the sequence. Then write a conjecture on how to find the next term. So maybe we need to figure out the pattern, write it down as a conjecture, and then fill in our blanks. So looking at those numbers, 38 to 31, it looks like we subtract 7. Did we keep doing it? Looks like it. So to generate the next term, we subtract 7 from the previous term. So 17 minus 7 is 10, subtract 7, we get 3, subtract 7 again, negative 4. Keep subtracting subtracting 7. Oh my. Add a negative 7 or subtract 7. There's the next 5 terms. Let's look at the next one. We have arrows. The first one's going up, then the right, then down. It looks like it's rotating 90 degrees clockwise every time. So the next one will be left, then up, to the right, down, and to the left. Find the pattern of the sequence and write a conjecture and draw the next figure in the sequence. So if we look at the first one, that is a 1 by 1 square. That one's 2 by 2. This is 3 by 3. So I'm thinking the next one will be 4 by 4, which is going to look like that. Write a conjecture that describes the pattern in the sequence and use your conjecture to find the next item in the sequence. So they are looking at the total number of circles, and we have to figure out a pattern so we can see what's going on. So the first time we have 1, and then we add a row of 2, and under that we add a row of 3 and add a row of 4. So the next thing is probably add in a row of 5, which is going to look like this. And 10 plus 5 is 15. So our answer is B. Counterexample. If a food is a fruit, that's our condition, then it is an apple. That's the conclusion. That's our statement. It isn't always true. We need to find a counterexample. If the condition is true, but the conclusion is false, we have a counterexample. So you need to find an example of a fruit that's not an apple. So how about that? A mango is a counterexample. A mango is a fruit, but not an apple. Let's find some more counterexamples. What is it again? It's an example that shows a conjecture is false. So determine whether the conjecture is true or false. If it's false, you need to provide a counterexample. The sum of any sum. That's what you get when you add 2 things together. 2 consecutive integers. So those are numbers right next to each other, like 1 and 2, 2 and 3, 3 and 4, and so on. They're saying it's always odd. Let's try some examples. So 1 plus 2 is 3. 1 and 2 are consecutive. 2 plus 3 is 5. Those are consecutive. 3 plus 4 is 7. It does look like that's going to be true because those 3 examples, all the sums of consecutive integers are odd. Product is answer to a multiplication problem. So the product of 2 numbers is always larger than either number. 2 times a half is 1. Ooh, that's not larger than 2. What about 5 times 0? 0 is not larger than 5, so that's false. Either one could be a counterexample. You really only need one, but there's a couple of them. Product multiplication, again, of 2 perfect squares. Here's a list of perfect squares. A perfect square is when you square a number and that's what you get. 1 squared's 1, 2 squared's 4, 3 squared's 9, and so on. I just started with the list there. Let's give some examples. Let's see. If we multiply 4 and 9, those are both perfect squares, we get 36, which is a perfect square. If we multiply 4 and 25, it's 100. That's a perfect square as well. That is going to be true. Do some more. Determine whether the conjecture is true or false. If it's false, provide a counterexample. Area of a rectangle. So we need to remember what that is. They're saying it must be, the dimensions must be 2 meters by 3 meters. Area is length times width. So 6 is the product of the length and the width. And they're saying the only option is 2 and 3. Well, 1 and 6 works, so that's false. That's our counterexample. Dividing by 2 always results in a number less than the original number. Here's our number line. Let's take a look. If we do -8 divided by 2, you get -4. Look at -8 and look at -4 on the number line. -8's to the left, so it is lower than. So -4 is greater than, and that is going against what they say is going to happen. That is false. Vertical angles are never complementary angles. Well, they could both be 45, which should mean they're complementary, adding up to 90. Vertical angles always have to be congruent, just a reminder there. If A times B is 0, then either A is 0 or B is 0. That is true. You use that in Algebra 1 and so on with algebra. Zero product property. Let's see what is next. Show that the conjecture is false by finding a counterexample. So they already tell us it's false. Here's our conjecture. 2 complementary angles are not congruent. Well, we kind of already talked about that one. If 2 congruent angles are both 45, then they equal 90, which makes them complementary. So there's our counterexample. 2 supplementary angles are adjacent. So if 2 supplementary angles, so they add to 180, if they're not adjacent, then that's going to make our conjecture false. So those 2 angles are supplementary, but they don't touch. They don't have a common vertex or common side, so they're not adjacent. There's a counterexample. A definition, review of terminology. A definition is the meaning given to a term. It is the formal statement that describes what the term is. A conjecture is a statement that may be true, but has never been proven. It is a guess based on known information, but it has never been verified nor shown to be false. A postulate is a statement that's accepted as true without proof. It is used to prove other statements, often as part of a theory. We'll be doing proofs coming up here real soon. A theorem is a statement that has been proven true by accepted arguments. It may be deduced, for example, from definitions, postulates, or other theorems. In undefined terms, oh right, that's lesson 1, is a term that is not given a formal definition. In geometry, these 3 undefined terms are point, line, and plane.